most of the bananas which we buy from shops would be having these brown spots on them, right? This is called enzymatic browning. This is due to the oxidation of natural phenols in presence of various enzymes like polyphenol oxidase, catechol oxidase to cause brown pigmentation on bananas. This is an example for redox reaction. In our last class, we have discussed the classical approach to the redox reaction. In this video, we will discuss the redox reaction in terms of electron transfer. We have already discussed that oxidation means addition of oxygen or any electronegative element, and reduction simply means the removal of oxygen or addition of electropositive element or simply the addition of hydrogen. In the electronic concept of redox reactions, oxidation means a loss of electrons and reduction means a gain of electrons. During oxidation, there is an increase in positive charge or a decrease in negative charge, while during reduction, there is an increase in negative charge or a decrease in positive charge. You can use the code word oil rig to remember that oxidation is loss of electrons and reduction is gain of electrons. Now, let us take the example of sodium chloride. Sodium has an atomic number of 11 with electronic configuration 281 and chlorine has an electronic configuration of 287. Here, sodium loses an electron and chlorine accepts the electron to form sodium chloride as you can see here. Here, sodium is said to be oxidized and chlorine is reduced. If you look at this figure, you can see that sodium lost an electron and form a positively charged ion and chlorine is reduced to become a negatively charged ion. In this reaction, the part of the reaction that involves the loss of electrons is called the oxidation half reaction and the other part which involves the gain of electrons is called the reduction half reaction. And the sum of these two reactions is called a redox reaction as you can see here. Here, the species which loses electrons or undergoing oxidation is called a reducing agent or a reductant. Here it is sodium as it reduces chlorine. And the species which gains an electron or undergoing reduction is called oxidizing agent or simply oxidant. Here chlorine is oxidizing sodium by gaining an electron. Metals show the tendency to lose electrons and the ease of losing electrons determines the activity of metals. Let us explain this through an example by placing a zinc rod in copper sulfate solution. After around an hour, you may notice that the strip becomes coated with reddish metallic copper and the blue color of the solution disappears. This loss of color indicates that Cu2 plus ions in the solution has disappeared and there are zinc 2 plus ions present in the solution. The overall reaction would be zinc plus Cu2 plus gives zinc 2 plus Cu. Here, zinc releases 2 electrons, therefore it is oxidized and copper by gaining 2 electrons is reduced. Here zinc is the reducing agent and copper is the oxidizing agent. Now what about the reverse reaction? What if we put copper rod in zinc sulfate solution? Here we can confirm the presence of copper 2 plus ions in the solution by passing hydrogen sulfide gas into the solution. A black precipitate of cuprous sulfide would indicate the presence of copper 2 plus. However, passing hydrogen sulfide gas will not produce any precipitate within the solution. This confirms that copper does not release electrons to zinc and there is no copper 2 plus ions in the solution. Okay, so copper does not react in zinc sulfate solution. However, if you put the copper rod in the silver nitrate solution, you will observe a gradual change in color indicating that copper 2 plus ions is released into the solution. At the same time, we could also observe that the metallic silver deposit on the copper rod. This overall reaction would be copper plus 2Ag plus gives copper 2 plus 2Ag. Here, copper is oxidized by losing electrons and silver is reduced by gaining electrons. Now, if you compare the reactions we have discussed so far, we can see that the tendency to lose electrons decrease from zinc to copper to silver. This suggests that metals differ from each other by their tendency to release electrons. Now, based on the tendency of metal to release electrons, they are arranged in a series as you can see here. This series obtained when they are arranged in a decreasing order of their ability to lose electrons is called metal activity series or simply electrochemical series. The competition for electrons between various metals helps us to design a class of cells named as galvanic cells, in which the chemical reactions becomes the source of electrical energy. We would study more about these cells in class 12th. With the help of the electrochemical series and the concepts we have discussed so far, Can you try to predict the outcome of the reaction of metallic cobalt placed in nickel sulfate solution? With this, I will summarize this video.
Manorama Horizon. Learning made simple.